we're going to talk about negative exponents. You should have seen the rules of exponents before and internalize these a little bit. So all of these, right, nothing is new here. All of these up here are old rules of exponents. Okay, so these are the old ones up here. And then what we're doing is just adding a few onto this. So these bits here are the new ones. Okay, so that's new. Okay, so what do we mean by this? So let's just go over it. I mean, the more times you see these rules of exponents, the more they become internalized. So let's go over them, right? When we have the same base and we're multiplying a to the m times a to the n, the exponents add. Okay, they add together. Compare that with when you have a to the m and then you're taking it to another power. When that happens, the exponents multiply together. Okay. When you have two bases a, b multiplied together and you're taking them both to the n, it's a to the n, b to the n, not to be confused with a plus b to the n, in which case the exponent does not multiply through. Okay, when you're dividing here, a over b to the n is simply a to the n over b to the n. Okay, and then we start to get into a little bit of the negative exponent territory here with a to the m over a to the n. You subtract exponents. So these two are opposites, or I guess we can say this one and this one are related, right? When we're multiplying them together, we add the exponents. When we're multiplying the bases to different exponents. When we're dividing the bases, we subtract the exponents. So those two are related. Okay, and then the old standards, right? When we have a to the 0, that equals 1. Anything to the 0 equals 1, except for 0 to the 0. And then anything to the 1 equals itself. Okay, so that gives us the basics. Now what we're doing is adding in a couple more. Okay, and a lot of these kind of fit together. These are really the one that we're adding in is this. A to the negative n, well, that's the same thing as saying 1 over a to the n. Okay, so it brings this negative exponent, brings the a to the n down to the bottom. All right, now suppose the a to the n is already down on the bottom, like in this case. No problem. If it's a to the negative n in the denominator, it pops it back up to the top. Okay, so all this negative exponent does is bring it to the other side of this major division line here. Pops it back up, and we're left with a to the n. Okay, very useful stuff. A corollary of these two is this. A over b to the negative n, what this negative does is just basically gives us the reciprocal. It takes a over b and makes it b over a. And now notice it's just to the power of n. The negative is gone from the exponent. Okay, so these you should also internalize. This will pay dividends for several sections in the future, right? This isn't one of those one and done sections. This is the kind of thing you'll see again and again and again. So spending some extra time now with these rules of exponents to really internalize them will pay off big time down the road. One important thing here, a note of caution. Okay, let's just see here. Here's a common mistake. A to the negative n, I'm going to say does not equal negative anything. 1 over a to the n, it does not equal negative, 1 over a to the n, that's what I meant, or negative a to the n, or something like this. This negative up here in the exponent never comes out to the front here in this context, right? So one of the mistakes that I see often is that somehow this negative exponent, this negative creeps down to the front and people want to make their entire expression negative. That does not happen, right? All it does is it moves this a to the n down to the denominator there. No negative out to the front. Resist that temptation. It doesn't happen. Now that we have all our rules of exponents together, let's do a couple of examples. So let's see, maybe we have something like this, 6 to the negative 2. And the directions on all these kinds of examples are to write with no negative exponents in the answer. Right? So whatever you do in all these problems, you want to make sure that there's no negative exponents left in your final answer. Okay, so for instance, we have 6 to the negative 2. All right, so I'm thinking we're using this rule right here. So this is going to be 1 over 6 squared, 1 over 36. There we go. All right, so notice that this isn't negative 1 over 36. This negative, all it did was bring our 6 squared down to the denominator. Let's try another one. So we have 7x quantity to the negative 3. Okay, so this negative 3 is applying to all of this 7x. So what it's doing is sending all of the 7x down to the denominator, 7x, and now it's just 3. Once we move it down to the denominator, we get rid of the negative in the exponent. Okay, so now it's just 7x to the power of 3, and now we're using this property here. A, b to the n is a to the n, b to the n. Okay, so this 3 is going to come through to both of those. So it's going to be 7 to the 3 times x to the 3. Well, 7 cubed, you might have to use a calculator for that. It's 343 x cubed. There we go. All right, so just getting the hang of some of this. Let's try another example here. Let's do 1/8 to the negative 1. Okay, well, I'm going to use this property here, which tells me to take the reciprocal of the inside and get rid of the negative exponent. Okay, so that gives us 8 over 1 to the 1. Well, 8 over 1 is just 8, and 8 to the 1 is just 8, so this comes out to just 8. Now, here's where you start to see multiple different ways of doing things. And that's kind of the cool things with these kinds of, one of the cool things with these exercises is there's so many different ways to approach these and get the same correct answer. For instance, here now I'm going to do the same problem. I'm going to do it a completely different way. This time I'm going to use, let's see, I'm going to use this division property right here, and I'm going to take this negative 1 through. So we have 1 to the negative 1 over 8 to the negative 1. Okay, well, this takes this 1 to the negative 1 down, and this 8 to the negative 1 brings the 8 up. So we have 8 to the 1 over 1 to the 1, but 8 to the 1 is just 8, 1 to the 1 is just 1, and then 8 over 1 is 8. Totally different approach, same correct answer. So as long as you're correctly using these rules of exponents, you'll get the correct answer. Let's try another one. Let's do 4 to the negative 2 minus 4 to the negative 3. Again, we want to write our answers with no negative exponents. All right. Well, let's check out this property right here. So 4 to the negative 2, that tells us we're moving that down to the denominator and getting rid of the negative exponent. So this is 1 over 4 squared minus 1 over 4 cubed. All right. So 4 squared is 16 minus 1 over 4 cubed is 64. All right, so now we have some fractions we need to subtract. No problem. We need the common denominator. Note that 64 is divisible by 16. 16 times 4 is 64. So our LCD in this case is going to be 64. 64, right? These common denominators are always challenging. Even up into calculus, there's still kind of something that you have to pause for a little bit and think about. Okay, so we have now 4 minus 1 all over 64. Okay, 3 over 64. There we go. Let's try another one. How about this? Maybe some of these aren't so bad. Maybe it's something like this. R to the negative 5 over S to the negative 2. All right? So what this tells us is to bring the R to the 5th down and bring the S to the negative 2 up. Okay, that gives us S squared up top over R to the 5th down below. That's all there is to it. So don't overthink some of these. Right? Some of them are really just getting warmed up. Okay, let's try one more here. Let's do negative 1 over y to the negative 6th. Okay, well this negative 6th down below, we're using this property here, right? It brings it up to the top and gets rid of the negative. But this negative out front is just going to hang out, right? Nothing affects that whatsoever. So this negative in the front is still there. Y to the 6th comes up, so negative y to the 6th. And that's it. So spend some time with these rules of exponents. Make some flashcards if you have to. Do whatever it takes to deeply memorize these. And remember, this is not the same as a plus b to the n. A lot of people get misled here and they start making this mistake. But this is much different when we have a plus here. So this only works with multiply. But yeah, work through these, internalize them. They will pay dividends moving forward.